Good afternoon, everyone. Today we're going to solve a question where we're given the cos of theta being 1/5 and the tan of theta being 2 root 6. And we're asked to find not theta itself, not the angle, but just the exact value of the sine of theta, or the ratio of sine theta. Okay? So to do that, let's start with the cos theta. We know that cos theta, which is given to us as 1/5, is equal to the ratio of the adjacent side length over the hypotenuse. Right? And we're told that tan theta, which is 2 times the square root of 6, is equal to the ratio of the opposite over the adjacent side length. Right? This is just from SOHCAHTOA, right? You guys get it? Now, sine of theta is the ratio of the opposite over the hypotenuse, right? And so how can we use these two to manipulate them so that we end up with the opposite over the hypotenuse? Well, you might notice that if we do a over h times o over a, if we multiply these, the a's would cancel out if we think of it algebraically, and we'd be left with o over h. And so that's one way to do this. And so if we multiply a over h times o over a, you'll notice that algebraically, this is a rough, I'm using this term loosely, but the a's would cancel out, and all we would have is o over h, right? And now we said earlier that a over h is 1/5, so this is like saying 1/5 times, we said earlier that over a was tan theta, which is 2 root 6. So over a, this quantity, is 2 root 6. And now this times that, we said was O over h. And O over h, opposite over hypotenuse, that ratio is precisely that sine theta that we were hoping to find. And so now we can multiply these two quantities, and we find that 2 root 6 over 5 is equal to sine theta. And that way we didn't have to find the theta angle itself using inverse tan or inverse cos or anything like that. We could just manipulate the ratios in the way that we know it. Sine, cos, and tan are connected to find sine theta in this quasi-algebraic way. Okay? So I hope that helps. Thanks for watching.